Good morning, sir.
Good morning. How are you today?
Quite well.
Excellent.
Just opened the lab, so there's some that are still logging in down there.
Oh,
Hello,
so
Vitaly.
Good morning, Professor, and good morning, Professor.
hello.
How do you like being up this early?
You know, it's actually not too bad.
Really?
I don't know, it's kind of a nice start to Tuesday, and then by the time lab is done, it's only 10 a.m.
You can go take a nap.
Yes, but I go to work right after this, so it's kind of nice. I get more hours in the day.
Oh, that's good.
Where do you work, Vitaly?
I work at Pacific Power.
Mm.
Good morning, Bernard.
Hello, Bernard.
Good morning, Professor.
Morning. How are you today?
I'm doing fine. How are you, sir?
Just fine. How was your breakfast?
Not yet. I ate breakfast late.
Late.
Yes, sir.
Bernard?
Good morning, Dr. Ballard.
Good morning. So, when you're home at your home country, what do you have for breakfast?
A lot of them same as here, and some variation of others.
I see.
Is it vegetable?
Pardon me?
Vegetable?
Some vegetables, some flour-based. Yep.
A certain Egyptian friend of mine always makes fun of me because he doesn't think I eat a good American breakfast.
A good breakfast is always fuels the body very well for the day.
What is a typical Russian breakfast, Vitaly?
There's also several variations, but I like scrambled eggs, maybe an omelet with some buckwheat, and this very particular dish called pirashki. They're like potato stuffed latkes. Very good. When my grandmother makes them, I love them. Also, we have our own Russian pancakes, but they are like crepes, basically. They're just a thin consistency. So I'll have to make you some sometime, Professor.
Are there Russian restaurants in USA?
Yes, definitely. But they're only in the major city hubs like Portland, San Francisco, Los Angeles, Sacramento. Yes. And when I'm in Portland, I like to go to the grocery store and buy their imported foods.
What does the average Egyptian eat for breakfast?
Beans.
Beans?
Yes, beans.
Rice too, or just beans?
No, beans.
Uh-huh.
Are there people in the lab? I cannot see anybody.
Well, I'll walk out there and nag them because I let people in.
Oh, you did?
Mm-hmm.
But they are not online.
I'll go down there and see what's happening.
Please do.
I want extra credit for this.
It depends on how many you are gonna get.
Okay. I think he was working away and forgot the time.
Okay,
He's logging on now.
okay. Hello, everyone. Who is in the lab? They are not in yet, Jim?
I don't know. Who's in the lab?
It's me and Mr. Castillo.
Only two of you.
Yes.
Okay, thank you. We may start now. We'll continue our talk about the state machine. We started that yesterday.
Can you make it bigger again? Oh, that's better. Thank you.
Here in this one, I have how many states? 1, 2, 3, 4, 5, 6, 7 states. And each state, it has an output. The state has an output, each one written beneath it. And according to the input, I move from one state to the other. And this is a typical Moore machine. Typical Moore machine. The output here depends only on the state. It doesn't depend on the input at all. So I move from one state to the other depending just on the input. We are going to see how we may implement this in a code. And this code will be a very general one, and you can apply it to any state machine. First of all, I included the libraries, IEEE, and the packages that I'm going to use out of it. Then I have my inputs, clock, reset, input, X. But X, it is a 2-digit. Y, it is another 2-digit. So I have those are my input. And now I go to my architecture. In my architectures, I have here two signals. Two signals, those will denote my state and my next state. My state and my next state. The state definition, I have 7 states and it is fully encoded. So I don't have 7 digits. I have only 3 digits that can define the 7 states, and those are as shown here. As you can see, my signal is state and next state. Begin. Process, clock, and reset. This reset is independent of the clock. So it is a synchronous reset. If reset is high, I should go to state 0. Else if rising edge, next state will be assigned to my state. My next state will be assigned to my state. We still need to know what is my next state. Here is the brain of my whole process. The process here, as you can see, it depends on the state and X. It doesn't depend on the clock. The clock here, it is for moving next state to be my current state. But here is the logic. I am using a case statement. Case state is 0, 0. That means I am at the first one. If X is 0, 0, can you see this? I am at state 0. This is my state, S0. And I have the input 0, 0. My next state will be 0, 0, 1. What will happen if I don't have the input 0, 0? I should remain where I am. No change. This is if X 0, 0. My next state will be 0, 0, 1. Else, I will remain where I am. Vitaly?
Yes, Professor.
I am at S1. That's why I am saying if I am a state when the state is 0, 0, 1, this is my second state. Now, what is the condition for me to move from state 1 to state 2?
Let's see. So S1 needs to be 1, 1, as it shows there. Oh, does the input need to be high?
This one, it tells you this is my input.
Right, 1x. So it needs to be 1.
1x. What is meant by x?
X being one of your inputs on the array.
X. I have I have input x that is 2 digits.
Right. So it's either one or
Here,
zero.
here the two digits are 0, 0. But here the two digits is 1x. I'm asking, what is x?
I understand. X is I forget the exact technical term. Is it a don't care?
Don't care. Yes.
Okay.
X
So
is don't care.
it can be one and basically anything else.
Yes, it can be 1 or it can be 0. We don't care. That's why, can you see here, I'm saying x of 1. X of 1 means the second digit. If I say x of 0, this will be the first digit. But here I'm saying if x of 1 equals 1, well, that is my next state will go to S2. S2, it is 0, 1, 0. Else if Bernard, hello, Bernard.
Yes, Professor.
Here I am at this stage. What is the condition for me to move to S3? What should be the input?
Yeah, the input is 1, 1.
Where did you read it? This is the output.
Oh,
I'm at
this
state 1. This is the output.
yeah. Or 0x.
0x. That means I don't care about the least significant bit. I care only about the second bit. That's why I said here, if x of 1 is 0, I will go to state, this is 1, 1, 0. That means state 3.
Yes.
Chad? Hello, Chad?
Yes, Professor.
I am at stage 2. Stage 2, that is 0, 1, 0. Now, what is the condition to move to state 4?
X would have to equal 1, 1.
That is what I said here. X equal 1, 1. I'll move to next state. Okay? Else, do I have anything else, anywhere else to go?
Back to itself.
Yes, go to itself. That is, if I don't have 1, 1, I would remain here forever. And that is clear here. Else, I will remain in the same state. Now, we are entering state 4. Jose?
Yes.
We are here in 4. How many options do we have? How many places could we go to?
There's S3 and then S6 and then back to S4.
S3, yes, and S6, yes, and S2, yes. Is there any place else?
What about that arrow with the 0 zeros? That one.
This means remain as is, no change. Stay where you are.
Makes sense.
Okay. That's why here I'm stage 4. I have 4 options, including the last one, that is remain where you are. I can go to stage, as you said, 3. I can go to stage, this is 6. This is stage 2. I can go to any state of those 4. Okay. Samuel? Samuel?
Yes, sir.
Here I can go to 4 places, to 4 states. If I want to move to a 5th state, what should I do?
If you wanted to move to another state, would you have to create
State
like
number
another?
5. I have here
Uh,
7 states.
You could either go back to 3 and then to 5, or you could go to 6 and then go back to 1 and restart over, or you could create another if statement and create another path directly to S5, depending on how you want to build your logic.
That could do it, but it is very complicated. Isn't there any easier way? You can see I ran out of options. I have
You
0,
could
0, 0, 1, 1, 0,
could
1,
you
1.
just charge all your states? So hit like a reset or something, and then have it all
No,
trigger 1? No.
it is easier. What will happen if I have this X? Instead of 2 digits, I have it 3 digits. Would that expand my options?
Yes, I think so.
Yes, X is my driving. I go by the value of X. I have 2 digits, that means I have 4 options only. If I want to get more options, X must be larger. 3 will give me 8 options. Okay?
I see what you did.
Okay. Now, we are in state 5. State 5 will go automatically to S1. As you can see, XX.
That's state 6 on mine.
Oh, sorry, 6. Let me read one more time. Yes, when we are in state 5, where is 5? Here is 5. Yes, this 5, it doesn't care, and it will go automatically to 6. It is written in here, we are in state 5, and my next state will be 6. If I'm at state 6, I will go automatically to 1. Okay. When others, okay, I am state 0. If it doesn't fit any of those, I will go back to 0. This will move you from one state to the other. We haven't spoken about the output. We are building this machine for the output, so we need output. Here, as you can see, the output depends on the state. So this process is dependent only on the state. Case state, when you are in state 0, the output is 0, 0. When you are in state 1, the output is 1, 1, and so on. So the output depends on the state because we are speaking about a Moore machine. A Moore machine. Reminder, we have inputs, clock, reset, and X. And Y will be my output. That is Y is my output.
Professor, why do you use 3 bits and then 2 bits on the output?
Three bits for what? 3 bits for the state.
Yes.
Yes, because I have 7 states.
Oh, okay. That's right.
Okay.
Perfect. Thank you.
And the output, it is my option. I selected my output to be 2. I can make the output 4 states, whatever. But when you are saying we are fully encoded, so the number of states must be accommodated by the number of digits. The next slide shows you the test bench that we may use, or you can use the normal waveform generator. And this is my output, the results. You can get the same results from waveform generator, provided that you are giving it the input. I need this input. This is my clock. And reset will be high for the first 2 clocks. And this is my input. My input 0010, 0011. I need this input so you can see your outputs. Okay. I'll let you work on this. Then we are going to speak about the Mealy machine. This is a Moore machine, and I believe you have my slides. So I will stop sharing. Any one of you may share, may discuss with others. Okay. We have about half an hour, and I'll check on your status then. Thank you.
Professor, are we doing part 2 of the lab or homework?
No, at the moment, we are doing this assignment from here. Just a moment. Go to my slides. I need you to do this, slide 18.
Okay.
Okay, slide 18.
Hey, Professor.
When
can I
you
sh-
finish with slide 18, this is the Moore machine. We're going to go to the Mealy machine. When we finish those two, you are to do the assignments. The homework assignment, you can do it on your own. We are not going to discuss it in here. We discussed it yesterday, and you know what to do. The lab assignment, we are going to get to it after we finish those two. Okay?
Hey, Professor, would it be all right if I showed you, let me mute that. My board.
Showed me what?
So I got the board to work finally. I was
Ah.
having trouble with IT support, but I think I got it to work.
Excellent.
All right. So. Let me bring up my code. Let's see. All right.
Which one is this?
This is the old one. This is the basic code for.
I am just watching the old one. You may go ahead and work on the new one.
Okay. So this is just compiling everything. I think this was just the on-off switch that we created in the lab before we created the all.
Yes, yes. Just show me the board as it is running.
Okay.
The light emitting diodes as it's running. That's it.
Okay. Let me pull up because I don't think I have it on the board yet. Okay. So it turns this bit over here on, and then I can turn that, and it turns that bit on, far end. And then this button turns the one on the end. I'm not sure if you
Okay.
can see that.
Yes, I can see it. Thank you.
Uh-huh. So it's no longer reading the default code where it's counting
Okay.
up, and I can get it to work. So thank you, sir. I appreciate
Excellent.
it.
Thank you. Okay.
I'll stop showing that.
Professor, just clarification, quick question. Professor? Hello, Professor. Yeah, quick question. So we're doing slide number 18, correct?
No, the whole program.
Okay.
Slide 18 is not the full program. The whole program is like there are 3 or 4 slides as it is.
All right, thank you.
Thank you.
Would we eventually be uploading this to our board?
You don't have to.
Okay.
Hey guys, how do you get rid of so if you have this icon underneath what you're typing, and when you type, it deletes everything in front. How do you get rid of that?
The insert.
There's a key on the upper part of your keypad called insert, and click it, and it changes it between insert and something else. I accidentally hit it all the time, so.
Thanks.
Vitalik,
Yes, Professor.
I'm unclear here about double quotes, single quotes. Sometimes there's double quotes to this, and sometimes, like he says, if X1 is equal to single quote 1, close single quote. And then up above, he says if X is equal to double quote 0, 0, double quote. Is it all supposed to be single quote here?
No, because when he does a single quotes, he's referring to the specific X and Y inputs, versus the double quotes are referring to the output state. So for example, when he does the single quote, like in the second line, when, double quote 001, if X of 1 equals 1, do you remember like in that state diagram when it shows there's like a 1X?
Mm-hmm.
So it means like as long as the most significant bit is 1 and the least significant bit is a don't care. That's what that's implying, is that this is a variable now. So as long as it has the 1 as the most significant bit, then the rest doesn't matter. But like in the other sections, he's very clear, like you're explicitly stating, if the condition, like if the input is X equals 1, 1, double quote, meaning like both values are assigned there specifically, then you can move on to the output. Does that make a little bit more sense? It's basically because
Well,
where there's,
look at line 44 and then line 50, okay?
okay, right. So like I think in I believe it's line 44, he has double quotes because he's specifically saying that when the condition is 0, 0 on the input,
Mm-hmm.
that's like a clear definition, but you have to write it as kind of like a variable with single quotes in line 50, because when early in that line 49, it says when 001, if you go back to the state diagram 001, the code again. All right, basically it's saying that's at state 1. If X of 1 is 1, meaning the most significant bit on the input is 1, we can see going to the left from state 1 down to state 2.
Yeah, but why is there double quotes in line?
Double quotes for more than one digit. Single quote for one digit.
There we go.
I see.
Thank you,
Okay,
Professor. Better explanation.
Thank you.
I wish I was a better typer.
Any good news?
Still typing.
Hello,
I
Paige?
got my waveform to show up, but I don't think it's showing up correct. I could show you. Let me see it.
It's not working.
Um,
Is it working?
yes.
Did you give the same input as seen in the test bench? The
Let
same
me try
input
that.
as the test bench.
Okay.
Try to formulate the input to match the test bench.
Okay. Let me
If
try
it
that.
gives the same output, you are on the right track.
Okay.
Thank you. Hello, Paige. Paige,
Hello? I am still typing. It
no, I'm
hasn't been
not asking about
compiling.
typing. I'm asking about the match.
What?
The game on Friday.
You know, Professor, it did not go the way we hoped.
Oh,
We played hard, we did our best, but we did not win.
Where were you?
It seems that they didn't feed you well. If you eat well, you are
Exactly.
gonna do better. Okay.
That's exactly it. We were in Eugene in Salem for our games.
Very nice city, Eugene.
Yes.
Is it better than Klamath?
It was very rainy, which I was surprised. And it snowed a little bit.
No, in general, do you think it is better than Klamath? Not the weather, the city itself.
I think both have their positives, but I think I like Klamath better.
I couldn't see any positive in Klamath except the students and the colleagues over there.
That's a good point. But that's
But
the reason why I say
at
Klamath.
least in
because
Klamath, you have the option to go over the weekend. You have many options. You can go to Walmart, you can go to Fred Meyer's, many options you have.
That's
But in
very
Eugene,
true.
where will you go?
Oh man, this is true.
Welcome back.
Thank you.
Professor, I think I have the right idea going on in my waveform, but can you check to make sure?
What do you want, Vitali?
Oh, I was just saying that I compiled my waveform and I think I have the right idea, but do you think you could check just to make sure?
Do you get the same output as the test bench?
for the most part, except on the standard waveform, you don't have the option of displaying the state. So it's just the X and Y.
No, we don't need the state. I need just to see the output matching the output for the same input. That's it.
Ah, then yes.
Okay, go ahead, please.
Can you see this here? So I basically just adjusted these X input values, just like on the test bench. And I think my end time is a little longer than on the test bench, but I just adjusted for the scale with the clock. Do you need me to take a picture of this or screenshot it or anything like that, Professor?
Stan, do you think it is matching? I want you to check both and you tell me just one answer, matching or not matching for the same input.
Yes, I followed the same inputs from 0, 0, 1, 0, 0,
And
0.
we are having the same output. It is matching. Thank you. Stop.
Okay, yes, perfect. Thank you.
Stop sharing and wait for the others.
Okay, thank you.
If you check the announcement, you are gonna find the test bench of this state machine, the Mealy and more. If you wanna use it, you can use it. If you wanna use the waveform generator, you can use the waveform generator, whatever you like. Cameron,
Yes, Professor.
how's it going?
Very good. I finished the assignment.
Okay. If you are done, would you please try this test bench that I send you?
Yes, I can try that.
Okay, thank you.
Can I get
Vitaly,
Yes, Professor.
what did you set your, not your Clark, but your X's for in your test?
Right, so I actually just matched mine to the test bench waveform and the slides. I made it 90 seconds as the end time, and then I made my grid size I made my grid size 10 nanoseconds, and the clock was 5 nanoseconds. And I just like made it to scale, just like the test bench. I just matched the X input values and the Y output values simulated just fine.
Well, on the Morse SM simulation results, he has X goes from 1, 0, it goes up to 15, and then it goes clear to 35. Then it goes to 45. So is he just doing it at 10 or what? I don't understand how he can change it like that. I can understand on a test bench, but not on the variable waveform.
I'm compiling my code once more just so I can do the waveform from scratch, and I'll show you. Mr. Ballard, can you see my screen here?
Yeah,
So what you can do, like, for example, I want to make this one right here, this segment from this falling edge to this falling edge, 1, 0. All I would do is just highlight this. And then if you go up here where it says arbitrary value, you can set this to whatever you want.
I did not know that. Thank you.
No problem. So that's how you would do that. So just match them based on the falling and rising edges. And then if you run the simulation, you should get the exact same thing that he gets.
So which one do you hit for arbitrary values again?
It would be,
The thing next to C?
yep, the question mark one.
Oh, the question
Arbitrary.
mark. So 2
Yep.
down. Okay, thank you.
Not a problem. Thank you.
Can I get some help with an error for the wait for? It doesn't seem to be compiling right for me.
Want to share your screen so we can help you?
Okay. So line 40 right here, wait for 5 seconds and process.
Is this for the Moore machine?
The state machine, yep. Hang on, let me go plug in my laptop. It's about to die. Hang on. Okay, I'm back. I can run it again, I suppose. I don't see the mistake I made there. Does anybody have any ideas?
I'm trying to run it myself and I'll let you know.
Hey, Professor, I have a question.
Go ahead.
Hello.
Go ahead.
I'll just share my screen because I can't get the waveform to work for the more simulation.
It is not working at all or not giving the right answer.
It's not giving me the right outputs.
And it is the same input?
Yes.
Okay.
So this is what I keep getting.
You are getting nothing. It is not working.
Yeah.
Okay.
And I check my codes and it's the same as the one on Canvas.
No, it is not the same.
I'll show you my code.
Your X is not changing. Your reset is not changing.
Oh wait, that's
It
not
is
the
not
one.
the same input.
That's not the one, sorry.
You have to have the same input. Do you
Can you
understand
see-
what I said?
Yes. Can you see my screen?
Yes, I
Oh.
can see the screen. Reset all zeros and X is all zeros. So it is not the same input.
Well, I opened, it's because I was showing you the wrong one. I opened the one that's clock is 1 and reset is 1.
This is what I see.
Oh, let me see if I can change screen. Hold up. Okay, I think that should work. Let's see. Sure. Okay, can you see it? Can you see the new one now?
It is not the same input. Now I can see no clock at all.
So there's a clock reset, and then there's the X.
Those are not the same. Stop sharing. Stop sharing. Can you see this?
Yes.
I need this input, slide 24.
Yeah.
Get this slide input 24 and see the output.
Okay.
Okay.
I'm still having trouble putting that into variable waveform because the X's are not changing. I don't know how to set X is equal to 0, 0 for 15, and then X is equal to 1, 0 from 15 to 35, and so on.
Vitali? Hello, Vitali.
Yes, Professor.
Your uncle wants your help.
Okay, Professor.
Okay.
So I guess I didn't understand what you were saying about changing the X. So I want X to be 0, 0.
Vitali, show him your waveform generator and start a waveform from scratch.
No, I want to see how he,
One demo.
I want to see how he entered it.
Yes, he will show you.
Okay, no problem. 1 second. Let me open it. Okay, Professor Ballard, I'm gonna share my screen and I'm just gonna make one from scratch. So can you see the screen now? The
Yes.
waveform editor?
Yep.
Okay, cool. Let's get started. So yeah, I'm gonna set the end time to about 90 nanoseconds. And then I'll make the grid size. Oh, yeah, actually, yeah, we'll keep it at that. All right, now let's add our inputs. Goes over. Great, so we have these here. So I'm gonna make
Yep.
my clock by clicking on that, highlighting, I think you know this one. I'm gonna make it occur every 5 nanoseconds. Great, so we have that. I'm just gonna make the reset about this much.
And what did you click on there?
Okay, so I just highlighted this. Oops, sorry. Barely highlight this top segment. So you see how just the reset segment for
Mhm.
these two clock cycles is highlighted. And I just clicked on 1. I can make
One.
it 0 or I can make it 1. That's how you change the high
Okay.
and low values.
Okay.
So now that I have that set for X, I'm going to copy what he has. Let me just open that slide again. Actually, I have it right here. Okay, so from here to this falling edge, we're gonna make it 0. But actually, here's a little tip. You can't actually make it 0. It by default will go to 0. So I'm gonna go from this falling edge to this rising edge. I'm gonna make this 1, 0 for X. So I'll show you how I do that. Like I said, from this falling edge to this rising edge
Mhm.
in this X column, it's the top and bottom bar because you see it's all like one segment. If you just highlight like that, now we have that selected. And like I said, go up here to arbitrary value. And I'm literally just going to type 1, 0, hit OK, and it should go to it. And you see how this automatically became 0, 0 because there was nothing there.
Uh-huh.
That's how that works. So now we just follow the rest of the slide, like match his test bench. I did it once before, so I'm just going to refer to my own. That's why I'm going back to this. Okay, so this falling edge to this this falling edge to this falling edge is 0, 0. Or from here to here, we're going to make it 1, 1. So I'll do that now. Okay, so from here to here will be 0. So this is all we want. Highlight that again. One more time, go to arbitrary value. Type in 1, 1, hit OK, and boom, you got this part again.
Okay.
You see where
Thank
I'm
you.
going with this? No problem.
I've
me
never
know-
seen those used before, so.
Yeah, it's a little different, but it should work. Let me know if
Okay.
you have any more questions, and if you have any errors with the simulation, I'll help you again.
Okay,
Wait.
thank you.
Vitaly, what's your grid size?
My
again?
grid size, the grid size is 10 nanoseconds, which is like each block,
Okay, got it,
but the total end time is 90 nanoseconds.
got it. All right,
Yeah.
thank you.
No worries. And the clock is 5 nanoseconds, so it can occur within one grid time.
Well, you changed the clock, right, to 5 nanoseconds?
The clock is 5. Yep.
Okay, got it. Thank you.
No worries.
Thank you, Vitaly.
Oh, my pleasure, Professor. Always.
Is there anyone who wants to show us his output? Samuel?
Professor, I'm just
Yes.
double checking that as soon as we get the more machine, that is all we're doing for today.
No, I'm gonna tell you what you are gonna be doing on your own. Are you done with it? Is there anybody who can show us?
Hey, Professor.
Okay.
Hello?
Yes, sir.
So I've got an error. It doesn't like the wait for command. Line 37 still. Just wait for 5 nanoseconds. I don't know if it's a library I need to include, but it does not like this statement right
Do you
here.
have all the libraries stated before?
Yes, sir. Or maybe not.
No, you don't have them.
I need to put in the unassigned, don't I? Hang on.
This is the test bench.
Yes, sir.
The test bench I gave you.
Yes, sir. Hello? Yep. Okay. Okay. It still doesn't like that.
Have you used test bench before? Have you used the test bench before?
Mm, I think so.
No,
Did I not build it correctly?
no, because it needs some setup before you use the test bench.
I see.
Have you done the setup before doing this?
I got shown how to do it. No, I did not
Okay,
do that.
forget about test bench and use waveform generator.
Okay.
Okay.
I'm still having trouble with that line 42 though.
Forget about the whole file, the test bench. I don't need the test bench.
Okay.
Okay. Go to waveform generator. Use the waveform generator if you haven't used the test bench before.
So you're saying it. So are you saying use just the state machine code and then run a waveform?
Yes,
From that?
sir. Yes, sir. That's correct.
Got it.
Okay, thank you.
Yeah.
Yes.
No. I think it's. There you go.
Can I get some help setting up the waveform?
I believe Vitali did that. Okay,
Sorry.
you can
I'll just,
see the video after we finish. Now I'm going to share the screen and go to the next thing that you have to do. This is the Moore machine that you saw. And I believe most of you have finished this typing. And that was the input output results. Now we are going to go to the next machine, the Mealy machine. As you can see here, we have the same 7 states, and the conditions to go from one state to the other are the same. The only difference here is the output. The output before in this machine, the output, it depends only on the state. The output is just dependent on the state, nothing else. But here, the output depends not only on the state. This is the output beneath my input. It depends on the input. So the output depends on the state and it depends on the input as well. So to write this program, since it is identical to the one before except for the output, so the first few pages are the same. Everything is the same. I have no change. The only change will happen, this is the next state. You are going to have the same program. The only change that you are going to make, it is for the output. Here, as you may see, the output, it is not dependent on the state only. Now it is dependent on the state and X. So I have my case, this depends on the state. And if it is 0, I will depend on the input. Here it says if the input is 0, 0, the output will be 1, 1. Otherwise, the output will remain 0. For the second state, this one, state 1, this is my state, and depending on the output, on the input, is it 1? If it is 1, yes, the output will be 1, 0. If it is 0, it will be 0, 1. As you can see here, the output depends on the input. Let me look at the one that we had before. You see here how simple it was. It depends on the state. The output just depends on the state. But here, my output, it depends on the state and the input. So this part will be different. And when we go to this, you are going to find that for the same input, the results are different. Why the results are different? Because now I have the input is changing the output, not just the state. So you should get out of it this waveform. So we have two machines, Mealy and Moore, and I need you to finish those so we can start our lab tomorrow. I'll stop. Do you have any questions before I stop sharing the screen? Any questions? Of course, this state machine, we are going to transfer it to a problem statement. And out of the problem statement, I will decide on the states that I have and how to move from one state to the other and what is the corresponding output. This we are going to learn when we start working on the lab. But for now, I need you to have this structure running for Mealy and Moore machine. And all what you need to do is just to concentrate on building the state diagram. And then it is going to be very easy to translate it into your machine. So continue working on what you have and I'll be around. If you want to leave, you can leave. You know your assignment.
Well, Professor, you said there's some videos gonna be on Canvas.
Someone is what?
I'm wondering if you're gonna upload this Zoom video to Canvas.
Oh, it is upload. You are missing a lot. Would you go to announcement?
Yes.
Can you see any announcement regarding YouTube?
So announcements. Let's see. All right. Announcements, and then you say YouTube.
Yes. Is there any announcement about YouTube?
There's one on state machines and test bench. This is that one.
This is the last one.
Where's the YouTube? No, I don't see YouTube on. Oh, I see one on YouTube, videos, lectures, and labs.
Okay. Open it.
Got it.
What is the date of this announcement?
That was October 1st.
October 1st. So since October 1st, you haven't read any of my announcement?
Oh no, I've been to this YouTube because I found it like on YouTube.
Okay.
I just typed it in, but I didn't know if you were gonna upload it somewhere else because sometimes I don't know if that's the right channel.
Every lecture, every lab are uploaded. All of them are uploaded YouTube.
Got it.
But maybe it takes time. It is not immediate.
Oh,
It takes
okay.
a lot of processing time.
All right. Cool. I was just wondering. Thank you.
Thank you.
you want to see our program, or do you, and the variable waveform, or do you just want us to keep it?
No, I want to see it if it is ready.
Oh, I don't know what that is.
Yes, show me the program if it is ready. Yes.
Can you see my, oh, I lost you.
I see the screen. I see the output.
This, you see this screen? This is the
Yeah.
output?
Yeah.
Okay. And this is the program.
Okay. You may move to the second program.
Okay, thank you.
Professor, I'm all done with my with the more simulation.
Okay, go ahead. Share the screen.
Okay.
Okay, thank you, sir.
Hey, you say did you say we don't need to upload it to Canvas, right?
No, this is not uploaded to Canvas.
Okay, I'll just save it and yeah,
Yes, because you are gonna use it to build the other assignments.
right. Okay, I'll go ahead and start on the other one. Thank you.
And you can start working on the other machine, the last one.
Okay, got it. Thank you.
Thank you. Hello, guys. Hello.
Hello, sir.
Any questions?
Nope,
Okay. See you
typing
tomorrow.
away.
See you tomorrow then. Bye-bye.
Bye, Professor. Thank you.
Bye-bye. Thank you.